Hello everyone, my name is Manuel Rincon Plaza, a senior student here at Arkansas State Campus Querétaro, and today, for my Perspective Analytics course with Professor Hugo Flores, I'm going to present a research project focused on a random forest implementation. So, before we dive into the code, let's clarify the concept. Think of a single decision tree as one person giving their opinion. They might be biased or forced or focus on the ground details. A random forest is an ensemble method. It creates a forest of many trees, and in each tree gives a vote. And the forest chooses the prediction with the most votes. This is crucial because it reduces variance and prevents overfitting, giving us a much better generalization that a single tree could give us. So, to kick things off, I look at the common problem often discussed in a data science communities to understand the practical applications. Here is the link of YouTube of the problem. Our first case study looks at the MLB Hall of Fame. The objective here was to predict which player get introduced based on their stats. So, we treated this as a classification problem. We clean the data by removing no predictive noise like player name or clock stealing to focus purely on offensive metrics. The algorithm effectively distinguished between Hall of Famers and non-members. Here is where it gets interesting. The model achieved about 85% accuracy, but the feature's importance plot reveal a historical bias. As you can see, weighting average, the top bar was the strongest predictor over weighting power stats like home runs. This tells us that the model didn't just learn the data, it learned how to voters historically through performing old stats. Now, let's move to the main implementation, the Quine project, our main project. Here, we combine clustering, decision trees, and a random forest analysis. We didn't just want to predict, we wanted to find natural groupings in the data and then explain it. So, we work with a dataset of 178 wine samples containing 13 chemical features like the alcohol, malic acid, and flavonoids. Our goal was thoughtful. First, identify a natural groups, clusters, within unable data. Second, use a random forest to identify why those wines were grouped that way. So the step one was unsupervised learning. We use the k-means algorithm in Python, and then we initiate the model with 4 clusters and run it with a random state of 42 to ensure reproducibility. This allows us to automatically group the wines based on their chemical composition. So, what was the results? The clustering results show us that the cluster 0 was the balanced wine, the cluster 1 was the high school and very high proline, the cluster 3 was the acidic group, and the cluster 3 were the fully bullet wines with high flavonoids. These clusters labels are effectively became the target variants of our next step, the code of the decision tree. We first try to classify these new labels using a decision tree. It looked at the output and we got a 1000% of accuracy of 100%. Now, as a data scientist, we should be skeptical about the 100% because this usually indicates overfitting that the tree likely just memorized the training data rather than learning the pattern. So to fix this, we implement the random forest. We split our data into training and testing sets. We set up the classifier to be more robust, ensuring that we weren't just relying on one voter, but the whole assemble. Here is the execution code. We use random forest classifier and feed it into our training data. When we run the score and the test data, the data model had never seen before. We got a result approximately of 0.925 or 92.6% of accuracy. Looking at the classification report, the metrics are solid across the board. You can see high precision and recall for most clusters. The weighted average F1 score is 0.93%, confirming the model works well of the wine types, not just the easy ones. So to summarize the performance, we achieved 93% of accuracy. Unlike the decision tree that was overfitted but by 100%, this 93% is more realistic, robust results that generalize well to the new wine samples. But how did the model classify them? That's the black box problem. To solve it, we extracted the features importance by putting this data into a data frame. We can see exactly which chemical components the tree is most useful for making decisions. So the visualizations make it clear. Proline is the dominant factor with a score of 41. It is the primary chemical differentiator for these wine clusters. For outweighing flavonoids at 0.09 or alcohol at 0.06. This gives us a perspective insight. If we want to categorize these wines, proline is the first chemical we should look at. So, my conclusion is that by applying random forest, we didn't just get a high accuracy of 93%. We validated the proline content. It's the primary driver of these wine clusters. We successfully moved from a raw data to a clustering, and finally to a robust predictive model that explains the why behind the data. Thanks. I will conclude my presentation on random forest implementation. Thank you very much for your time.